Now that we've reviewed GCFs and grouping, we're going to move on to differences of squares and cubes. So difference of squares, and actually both of these are just nice little patterns to recognize that you'll just have to remember if you want to do some factoring. So difference of squares is when we see two values, both squares, and they have to be a difference. It has to be a subtraction problem. If it's not a subtraction problem, if this said x squared plus y squared, it's not factorable. So we could just move on. But differences, definitely factorable. So when you have your difference of squares, remember you'll set up two factors. And in each factor, you will put your square roots. So the square root of x squared is just x. So I'm going to put x times x. The square root of y squared is just y. So y times y. And then to create that minus, we would need both a positive and a negative value of y. And again, think about if you were to distribute this out or FOIL this out, you get right back to where you started. Difference of cubes, actually that's kind of wrong. For cubes, we can either do a sum or a difference, but again, that's cubes only. So I'm going to write it like this. I'm just going to do, I'll put it here. So I'm going to put x squared and then it can be plus or it can be minus. Oh man, how about I make it cubes? There we go. So how about x cubed plus or minus y cubed? Now this is, again, a different pattern, one that people don't always remember, but we're going to see if we can take care of that. So we will have two different factors. We're going to have a little one, and then we're going to have one that's a little longer. In the first factor, we're going to put our cube roots. So again, in dealing with x cubed, I would just put x, and with a y cubed, I would put a y. And the symbol between them stays the same as the original problem. So if this originally said x cubed plus y cubed, then I would put a plus. If it said minus y cubed, I would put a minus. Okay, so this first one stays the same. In our second factor, it's actually going to be more of a quadratic factor. Okay, so if I have an x as my first term, I'm now going to put x squared. So we square that guy. The last term in this factor will be the second term in that original factor squared, so y squared. Okay, so both the x and the y get squared for our second factor, but then there's a middle term. And the middle term is the product of the two terms that were in the first. Okay, so if I have an x and a y in that first factor, I'm going to put xy. Because you'll see when we do this, we will have some numbers in there. But these three terms are all based on what was in my first factor. Okay, first term squared, last term squared. And then the product of the two is the middle. Now, in terms of the signs, remember that first term had the same sign. So if it started as a plus, it stayed plus. If it started as a minus, it stayed minus. In my second factor, we're going to switch it. So if it started with a plus, we're going to switch to a minus. If it started with a minus, we're going to switch to a plus. So I'm going to write opposite. Okay, so it's opposite of what we had originally. The last sign is always a positive. Okay, so that's one thing you'll have to try to remember. But what might help is the word soap. I learned this several years ago, and it really helps me remember what goes where. This just refers to the signs. So the first sign is the same, that's the S. The second sign is the opposite, that's the O. The last sign is always a plus or always positive, and that's the AP. All right, so the word SOAP could be your acronym for remembering those signs. Okay, so let's try them out. So first off, we have the expression 9x squared minus 25. I don't see a GCF here. Remember, don't forget about those GCFs. So I don't see a GCF, and I notice that both of these terms are squares. So I'm going to factor this as a difference of squares. So I just need to identify what are the square roots, right? So the square root of 9 is 3, and the square root of x squared would just make x, so 3x, 3x. Then the 25, square root of 25 is 5, 5 and 5. And then for my signs, I need a plus and a minus. Again, if this had been a plus in the original problem, we would say this was not factorable. But because it's a minus, we can go ahead and split it up as a plus and a minus. So that's factored. How about the next one? 100x squared minus 49y to the sixth. Obviously, 149 are squares. We've got an x squared. Is y to the sixth a square? Can you take the square root of y to the sixth? Yeah, if you remember your exponent rules, um, if I'm multiplying two things together to make y to the sixth, I have some options. I can make it y to the first times y to the fifth, right? Because remember, exponents add together. I could do 2 and 4, or I could do 3 and 3. So if I'm trying to find the square root of y to the sixth, square root is the same factor repeated twice, it's got to be y cubed and y cubed. So really, just take that exponent, cut it in half, and you've got its square root value. All right, so let's go ahead and do our factoring. So 2 factors. Square root of 100x squared would just be 10x. Square root of 49y to the sixth would be 7, and then I can use y to the third for each. 7y to the third. I need 1 plus and 1 minus, and we are factored. So those are our difference of squares. When we see those perfect squares, we can apply our difference of squares. Now for the next couple problems, we're going to go for some cubes. I'm going to write out our pattern again real quick. So x cubed plus or minus y cubed would be x plus or minus y. And then x squared, change that sign. There's your opposite sign. Middle term is just xy, so coming from the original guys in the factors, and then always positive y squared. So there's the pattern that we'll be following. So when we look at 8x cubed minus 125, first we need to identify, are these cube roots? Or are these cubes? Can we take cube roots of these? Is there something cubed that is 8? Is there something cubed that is 125? And if so, those are the values that will be in our first factor. So hopefully you recognize 8 as 2 cubed. So I'm just going to go ahead and put my 2x. So that thing cubed gives me my first term. And 5 cubed is 125. So that means that 5 is the second term in that factor. I'm going to keep that same sign because this was a minus in the problem. It's going to be a minus in my first factor. Now my second factor is built on the 2x and the 5. We're kind of done with the 8x cubed minus 125. We're cutting it into pieces. Now let's base our second factor on the 2x and the 5. So first term becomes that first term squared. Okay, so it's 2x squared, which makes 4x squared. Don't forget to square the 2. Don't forget to square the x. Middle term is the product of the 2x and the 5. So 2x times 5 makes 10x. And remember that middle term always switches signs or has the opposite sign. So I'm going to change it to a plus. Last term, always a plus. And we will square the 5 and just make 25. And there it is. That's our difference of cubes formula. Okay, so the first factor shows the cube roots. Second factor, we do our squares. So the first thing is squared and the last thing is squared. And then the middle term is the product of those cube roots. Now, some of you might be wondering if we can continue factoring. And you'll notice that when we are dealing with a sum or a difference of cubes, either one, this quadratic factor never will continue factoring. Okay, it is done. Although it's tempting to try, and by all means, if you want to try, this thing will never continue factoring. All right? Okay, let's move on to our next problem. I've got 3y to the 6th plus 24. Now, first off, I'm thinking GCF. I see a 3 that will divide into both of those terms. So let's go ahead and factor out that 3 as our GCF. So that now leaves me y to the 6th plus 8. Okay, because if we had left the 3 there, we don't have cubes. 3 isn't a cube. 24 isn't a cube. But by factoring out that 3, I think we've now created something that does have cubes. So I'm going to go ahead and set up my 3. So now, if I want the cube root of y to the 6th, is there something that cubed will give me y to the 6th? Can I break this down into 3 separate terms? And hopefully you're thinking, yeah, it's y squared, y squared, y squared, right? If also you remember how exponents and radicals relate to each other, the cube root of y to the 6th can also be written as y to the 6 thirds. It's the exponent over the radical, which is called the index. And y to the 6/3 is the same as y squared. So we can see that y squared there. Okay, so either way, the cube root of y to the 6th is y squared. That's going to be my first term. The cube root of 8 is 2. And we always keep that same sign. This time it started with a plus. Let's keep that plus. Okay, now for the second term, I'm going to square the y squared. So y squared squared makes y to the 4th. I'm going to multiply the two terms together. That gives me a 2y squared. But I've got to change signs and go with the opposite sign now. So now it's a minus. And then my last term, always a plus, square the 2 and make it a 4. All right, so GCF is just hanging in the front. I went ahead and applied my sum of cubes formula this time. And again, this last trinomial may look factorable, but it is not. So if you want to try, by all means try, but I'm guessing you probably have better things to do than to try to factor something that's not factorable. Okay, so again, there are your sum and difference of squares and cubes patterns.